What the hell, man? Testing 1, 2. Am I live? Everything seems to be working, says Carlos. Hey, I'm live. And it's 2 o'clock. Oh, cool. I am so happy. I am using a Windows computer today, so I have completely messed everything up. I was trying to see if the Windows computer will be more friendly with this streaming software, and so far it seems to be working. So I got 3 computers here. I got the Windows computer, I got my Mac computer over here, which is not connected to anything, and then I have a monitor over there where I'm monitoring the chat. So cool. This is, let's see if I can get my screen to work. It works. Somebody says I get some microphone feedback. Wonder Bucket. That was Michelle. Audio is scratchy. Oh. That better? Terry Wheelock says meow. Does that mean it's working okay? Is my microphone still working? Yes or no? Fatbank says yes. So cool. Well, Wonder Bucket says no sound now. Oh, what happened? Let's see what will I do to get sound now. Yes. No interference also. I think it's my cord. I went back to my old audio cord. So cool. Well, welcome to another edition of RockSim Live. And it is live because we have technical difficulties. Johan says, is Wonder Bucket Michelle? And yes, that is Michelle. I wanted to get a new browser so that I could ApogeeRockets.com, so I could show you our website, because I'll need that. I'm on Windows today because every week I have problems with my laptop. See, I can't drag Windows around. Can't make this bigger when I want to make it bigger. Why won't it make it? There we go. Stretch it that way. I hope you can see my cursor. It's very small. We were like scrambling to try to get this to work, and it actually worked. But normally I make my cursor a lot bigger so that you can see where I'm pointing. And I can't do that today. So if you're brand new, this is RockSim Live on the ApogeeRockets.com website. This little picture right here is our RockSim Live. We are on episode number 107. Today is February 10. This is our archive page that shows everything that we talk about. And So if there's any questions, feel free to ask them. I do have a couple of questions that came in previously. I guess I can try those. Carlos says, has any motor manufacturer ever measured non-zero thrust from smoke delays? Or are we just making air pollution? Yes, Carlos. Basically, you're not making pollution. You're making it so you can see your rocket. So it's not pollution if it's useful. Once it dissipates, then yeah, I guess it is pollution. But there is no thrust from the delay smoke because the rocket, because it's burning so slow. To make thrust, you have to get enough pressure inside the chamber so that when it goes through the nozzle, it accelerates out through the nozzle. And it's just burning so slow that it's just not accelerating and making any thrust. So there is no useful thrust from any delay smoke. Rosa's here from Ottawa. Johan says, the manufacturing code problem of 2 weeks ago has been solved. I can't remember what that problem was, so I'm glad it's solved. All right, so let's see. The first question I had that came in was somebody was asking, Estes has got a new rocket called the Boss. So let's go estesrockets.com. And there's the Estes website. I wonder if they have the Boss, if it's for sale already. So you can see what it looks like. Because they were wondering how you can put in that fin shape. Because it's a round fin shape. And it's not showing. Okay. Oh, there it is. Look. Ah, cool. I can see it. This is what I wanted to see. Yeah, their website's really slow. But, yeah. All right. So let's. When I click on this rocket. Okay, so you see, it's very hard to see. Let me see if I can get this one. That's even more useless. Okay, so it's got one fin and it's perfectly round and it's on the side of the rocket. Let me see this view right here. Okay, so what do we got? We got two fins, one on the top right here, one on the bottom, and then attached to the one on the bottom is a circular one like that. Does this click? No, it's like I want to open image in a new tab. Let's see if I can get it this way. Oh, okay, there. That's much better. Can you see it now? Yes, we can see it now. Okay, so we're going to design this rocket because somebody wanted to know how to do this in RockSim. And yes, we can do this. All right, so that's what it looks like. I'll kind of move this off to the side, and then we will open up RockSim here. I got, what the heck happened? Okay, so here's RockSim. This is RockSim Pro. I'll do it in RockSim. Where's RockSim? RockSim Pro. I know I had RockSim open. Okay, I'll open it up over here. Okay, so now we are in RockSim. There's RockSim Pro underneath. Okay, so we're going to start designing this rocket. Let me see if I can slide this over so we can see the rocket. Not that one. That Windows, I think that was this one. Okay, so this is the Boss rocket. Oh, I want to slide it just right here so we could. It went to the other screen. All right, I'll leave it like there. Yeah, let's see if I can make RockSim smaller. Okay, so now we can see it. Okay, so we're going to start with it. We're going to start with the design, and we'll start designing with a nose cone. So if you're brand new to RockSim, you go here. We're going to call it the Estes Boss. Give it a name. We're going to use the RockSim stability equations. It's a single-stage rocket. This is a fairly complex design, so let's start designing it. So we're going to design it with a nose cone, and I don't know how big it is. I'm just going to guess, because if I try to go back to the Estes page here, does it tell me how big it is? Technical specifications. Okay, so the length is 28, diameter is 1.33, so that's a BT55. So I need a BT55 nose cone, so I'm going to go start by clicking on the nose cone, which I did up here. Then it always opens the database, and there should be a BT55 nose cone in the database, so that should be a PNC 33. Yes, right here, BT55. So I'm going to click OK on that. And this is the design screen right here. And then the one underneath is the main window. So let me make this one bigger. Okay, so there's our nose cone. And I like it, so I'm just going to say OK. Then we need a body tube. And I'm going to say that body tube is probably about 9 inches long. I'm just guessing, because I don't have the rocket kit. So to add a body tube, come over here to body tube, click on that, and it's got to be a 33 millimeter. Right here is our BT55. Click OK, and it added it to the design, but it's pretty long. It's 18 inches long, so I'm going to reduce that length to 9 inches and hit Tab, and so now it's shorter, and that looks okay. So I'll click OK there. I can change the colors. I like to change the colors so that I can see things. 2D color is blue, so we'll make it green. And 3D color, we'll make it white. Okay. So there's our rocket. And then we have this thing here. And this is kind of like a double transition. So we'll do a big transition and then neck it down to a smaller one. So we have to have the body tube highlighted, and we're going to go find the transition button right there. Click that. And this transition is not going to be in the database, and I know that because I have experience. So we'll just create it on the fly here. So here's the drawing of the transition right here. So it's fairly short. It looks to be like about a ½ inch from, you know, the top of the black to the high point right here. So that's the length. So I'm going to make that 0.5 inches. The front diameter is the BT55. So what I can do is I can come over here to shoulders, and on the front shoulder will be the part that goes inside the tube here. So I'm going to choose a compatible tube here, and I'm going to choose that as a 33 millimeter. And what that does is it automatically sets the diameter for me. And then the rear diameter, right now it looks to be like a point. We're going to choose that one. I'm going to make it a BT60, which is a 41.6. Click OK. So see, now that kind of looks correct, but we don't need this shoulder here. So now I have the shape that I want, but I don't really need the shoulders. There probably is a shoulder in here, but I'm going to make it a little shorter. I think it's 1 inch. I'm just guessing. But this one back here we don't need at all, so I'm going to clear the rear shoulder value. And it just cleared it out. And so now it's just that. So now we'll make this section transition right here. The material must be specified. Oh, that's good. He's through to an error. So to get to the material, go back to the General tab. And I'm going to say that this is polystyrene. And I need to give it a thickness, and it's not going to be solid. It's going to be hollow. And typical thickness is like 0.05 or 0.06. I'll make it 0.055. And I'm going to give it a color of black. In the 2D, I'll make it that kind of bluish color and click OK. So here's the front shoulder. And now I need this back shoulder. That one looks a little longer. That looks like about 0.75 inches long. And this diameter here, I'm going to guess that that's a BT50. So I'm going to do another transition. Again, it's going to look in the database. So I'm going to cancel out of that. Then I'm going to go to my shoulders again, choose a front compatible tube, and remember we said the front one was a BT60, so I'm going to click OK on that. And then clear the shoulder value, and then the rear one was a BT50, which is 24 millimeter, and this I do for memory just because I've been doing this for so long. And then the length we said was going to be this is 0.5. Nope, that's the shoulder. I'm going to go to the general tab. So here's the length right here. So let's make this one 0.75. Okay, so there we go. See, now this line right here is trying to create a shoulder. And also I'll say clear shoulder values. And that kind of sort of looks like that black part right there if you combine this and that. Let's go to the general tab again. Hollow 0.055. Color black, and we'll make it orange just so we can tell it apart. And then it has a shoulder, and that shoulder I'm guessing is kind of too long again. Let's make that shorter. Let's make it an inch long as well. Hit tab. So there's my part. I'm assuming this is probably blow molded. Estes usually does blow molds like that. Okay, so now we're going to have this tube here, and I'm also going to say that that's going to be about 9 inches long. I'm just guessing. So I'm going to add a body tube, and I'm looking for my 24 millimeter, which is a BT50. Click OK, and as you see it added it. And I'm going to change the length to 9 inches, hit tab. This is not a motor mount tube because it does look like there's a motor tube in there. So let's change the color here. I'm going to leave it at white. 2D color, we'll make it that color. Okay, so let's change the name on this just so that we can tell it apart. Let's call it the rear body tube. And click OK. Okay, so now we got that tube. Now we need the motor mount tube, and we need a parachute. So let's put those in. So inside the rear tube, I'm going to put an inside tube, which is the motor mount. And we'll click on that. Again, it looks in the database, and I'm going to say that this is an 18 millimeter. Let me go back here. Let's just double check. Yeah, so it's using a B44, B64, C65, which are 18 millimeter tubes. That tells me my motor mount is 18 millimeters. So I'm going to choose that one there. Click OK, and it added that tube right there. We're going to slide it back to the rear of the rocket, and it hangs out a little bit. If we look at that view right here, you can see it hangs out just a little bit out of the back end. And let's change the color. We'll make it white in 2D and green. So there's the tube. Now we need some centering rings. Let's call this the engine mount tube. And click OK. So there's our engine mount tube. Now we need to add some centering rings, and I'll add them. I'll click here. I'm going to add the centering ring here, and we need a 18 to 24 centering ring, and it added that ring right there. I don't know if you can see it. This screen is kind of small, so make it a little bit bigger so we can see it. Okay, so it's blue right now. It's right there. And it says it's plywood. It's going to be made out of paper. And let's see, it's got a thickness of 0.13 inches. I'm going to make that a 1/4 inch, so 0.25. And then the location, I'm going to slide it back to the front of the tube right there. We'll call it the front centering ring. Let's change the color. And the 2D color, I don't know, we'll make it green. Okay, so that's the centering ring. Click OK. So we got our first centering ring right here. Well, now we need to duplicate it and put another one at the back. So I'm just going to highlight it and then do a right click on it and select copy. Then come back up here to the body tube, select it, and then right click and do a paste. And you can see now we have two front centering rings. So it copied it and it put it in exactly the same spot. So now we're just going to edit this one and say we're going to call it the rear centering ring, and then we're just going to move it to the base of the owning part, and we'll make it 0. So I might move it just a hair inside the tube right there like that. Okay, so we got our centering ring. If we need an engine clip, which this rocket does have right down here, there's an engine clip. So that's a mass object, so I'm going to attach it to this engine mount tube. So I'm going to come over here to mass object, and I'm going to look for the engine clip, screw eye, engine retainer. Okay, standard size engine hook. So there's the engine hook. I'm going to select that, and it put it right there. So we're just going to slide it back a little bit in the rocket, and I cut it off there. I'm trying to make these screens bigger. Once you enlarge the screens, it remembers the size. Since this is the first time that I'm using RockSim on this computer, none of my screen sizes are remembered. Okay, so there's the engine hook, and I'm just going to slide it back using the location slider. I'm going to just slide it back to about where it would balance on the engine itself. Right there. All right, so I got a lot of people talking in the chat over here. I'm just looking at the chats right here, see if there's anything. Jeff is saying that we got more interference on the microphone. Crap. I'll take my phone and put it over here, and hopefully I'll play with the cord. It's this little piece of cord right there that I have kind of taped together. It's been giving me problems. Sorry about the interference on the microphone. Hopefully that's better. Okay, where are we? I'm still getting over my cold that I got when I was in Florida. All right, so we added the engine hook. Let's see, we need to add, click OK, so that's added. We need to add a parachute. So what size parachute does this kit have? Let's see if we can get some data on that. Recovery system, 18-inch plastic parachute. Okay, so I'm going to put the parachute in this tube. And that tube is right here. So you have to select it, so because it needs to know which tube it's going to go to. And that's why we select it. And then come over here to parachute, click on that. And it was an 18-inch plastic parachute. And you can see it through it right there. Okay, so I'm going to move the location. I'm going to just grab it and slide it here. And if I like everything, it's going to be fine. I'm just going to change the color. I'll make it red, and I'll make it red in 3D. So there it is. Okay. Okay, so now I'm going to save it just in case. Where's it saving it? It's saving it in my RockSim designs, RockSim 10 designs. And let's call this the Estes Boss and hit save. Okay, so there it is. Now let's start adding the harder items. Okay, so first let's add this first fin right here. And that fin is sticking right here down the middle. So that's a pretty simple fin. That's just a simple trapezoid fin. So let's do that. All right, so we'll put that on the rear of the tube. We're going to come over here, and that's a trapezoid fin, so that's just a regular fin. It's not a custom shape because it is just a simple trapezoid. It looks like all of the fins are going to be trapezoids except for that round one, and I'll show you how to do that one. That's what we were talking about here today. So let's add that first fin, and it looks in the database, and I'm going to always cancel out of that. Let's make this screen bigger so we can see things. RockSim puts a generic fin on the rocket. Let me make it smaller here so I can see the fin over here. Kind of gauge, I'm kind of guessing the size. We only need one fin. We don't need 3 of them. So that gets rid of 2 of them. And it looks like it's swept a little bit. And it looks a little bit stubbier than that. So I think that, and then I'm going to sweep it. I can either change the sweep angle or the sweep length. And maybe I need a little bit more root cord. Oh, no, it was tip cord. There we go. Oop, too much. So I'm trying to match this shape right here. And it goes all the way down to the tube. So maybe it needs to be a little bit taller. I'm just guessing. If I had an actual kit, I could measure it. We'll leave it like that. We'll make it yellow, because that's the yellow fin there. Okay, and in 2D, we'll make it that color. Click OK. So there's our fin. That's the first fin. Now, we got this fin on the other side, and it's a little bit shorter. But again, it's going to be a single fin. And that one is actually swept forward. So before I change this one, let's call this the simple trapezoid fin. Need the material, and we'll call it balsa wood. So I'm looking for balsa wood, 1/8 inch. I'm just guessing that's probably okay. Click OK. All right, so now we got this fin down here. So I'm gonna, I could actually duplicate that. Yeah, I think I will. I'll duplicate this one, do a copy, and then paste. Remember, when we paste it, it's going to put it right on top. So we have 2 simple trapezoids. So now we're gonna modify this one. We'll call this one the underside. Side trapezoidal fin, and then we need to move its radial position. So right now it's up here, but we need to move it down here, and that we can do with the radial position tab. And this is a radial thing, and I can just move it down to the bottom, and it's going to be at exactly 180 degrees. So I'll do 180 degrees, and it's exactly down. So now we need to just change the shape, and this one is swept forward. You know what? I think this other one is swept forward. Why do I have it swept backwards? So it's a little jumpy, and then I need to change the semi-span. This looks like to be the same length on the root cord and the tip cord. So if it's the root cord is 1.875, the tip cord also needs to be 1.875. Yeah, so that looks a little bit like that one. Semi-span, let's make it a little bit shorter. 0.6. Okay. Color is white, not yellow. Okay, let's just see if there's anything else. Okay, so this top fin that we did first is swept in the wrong direction. So I'm going to take the sweep length and sweep it forward. That looks better. I got one going sideways and one going vertical. Click OK. All right, so now we're going to get to this fin that's round, and it's attached to the top of this fin right here. So to do that, we got to use a component that's called the subassembly. No, pod. It's a pod. So we're going to attach a pod to the tip of this fin right here. So that's the underside trapezoidal fin. And I highlight it, and I can see that pod is selected. So I'm going to say, okay, let's add a pod. And let's make this screen bigger. You can see the location right now is right here of this pod. We're not going to eject it. And we're going to call this the round fin pod. And let's click OK for that. Okay, so right now it's still right there. You can't see it, but now we can attach a fin to this. So the pod allows us to attach a fin to it. So now I'm going to come over here to a fin, and this time we need a round fin, and we're only going to be we're going to break this fin into two parts, and we're going to split it right down the middle. So we have a fin on one side and a fin on the other side, and this is really simple to do. And this, we could use a custom fin, but we can also, in a regular fin like this, we have a choice between a trapezoid or an ellipse. An ellipse, if you do it right, it becomes a circle. So I'm going to go to fins. I'm going to cancel out of the database. And then we're going to make the count 2 fins. And right now it's going to put it right here. Let me switch this view. So right now I'm looking at a top view or a side view. Let's look at a top view. So I'm going to just change it here. So now I'm looking straight on that fin right there. And the root chord length, let me guess this. Looks pretty long. Let's make it like 4 inches long. 4 inches long. And the tip chord, we're going to change it from a trapezoid to an ellipse. And the semi-span right now is 0. So, okay, so it drew it, but now we can't see it because it's sideways. So let me go back here to this view. So you can see our trapezoid fin right there, or our elliptical fin. So now let's change some of the parameters here. So if I make the semi-span half of the chord, I should get a circle. So we have 2 fins. We have one fin here, and then the other fin is down here. And it's attached right here. We'll change that in a bit. I'm just changing. I'm just making sure that we got everything else. 0.18. Eighth inch is 0.18. 0.1875. No, point. What's an eighth of an inch? 125. I'm sorry. I can't remember my decimals. I was just changing the thickness. All right. So now we need to rotate that fin. So if I look at it from a rear view. So there's the fin, and I need to just rotate it 90 degrees. So I can do that again. Remember, we're going to use the radial position. And I'm just going to rotate it 90 degrees. And you see it's just flipping around. And I just want to get an exact number here of 90 degrees. So I'm going to hit 90 and tab. So now it's like that. Let me look from the side view again. That looks pretty good. Let me look from the top. Okay, so now we need to move the position this way. And I can't do it on this screen right here. Let's see, what color are we? Yellow. Let's make this black. Let's make it more grayish black. And in 2D, I don't know, purple. So there's the fin. Okay, click OK. So now we got our fin attached, but we need to slide it more forward. And to do that, I'm going to change the position of the pod that the fin is attached to. So this fin here, let's call this the round fin. So that we can tell it apart. And I'm going to change the attachment location. So right now the location is right here, which is right at, if I zoom in here, it's right at the 0 point where it attaches to the tube. So I can slide it forward. Let me zoom out a little bit. And you can see that it hangs down past the bottom of the rocket a little bit. So that's probably pretty good. And let's look at it in 3D. And zoom in. So you can see that round circular fin right there. It's kind of sort of looking like that. It looks not too bad so far. When we got it where we want, let's click OK. And so now we're back there. Now we've got to add these 2 pods here. And those, let's see, do they give me a base view? I'm just trying to see, I don't got a base view on this, so I can't tell exactly where those pods are located. So again, we're going to put a fin, a short stubby fin, and then this tube right there. So we'll make it so that they come off the sides just perfectly like this. They might come off at an angle, but that's pretty easy to change if we had to. Okay, so we're going to add another fin to the rear body tube, and it's going to be a simple fin. And let me see what that looks like again here. I can't tell, but I'm going to call it just, it's a straight rectangle, maybe about a ½ inch wide. So this is looking in the database, so I'm going to cancel out of that. And I want to go look at it from, I don't know, that view. Okay, so it drew 2 fins right here, or it actually drew 3, but we're going to call it 2 fins. So they're the purple ones. Let's change the color so you can see it a little better. Let's make them red. So there's the fins that I'm trying to draw, that these tubes that are attached. Okay, so let's go back to the General tab. Our semi-span, we're going to, like we said, we're going to call it a ½ inch. Make them short, and we need to make them a straight rectangle. So that the tip cord and the root cord have to be the same length. So 1.96, hit tab, and they have 0 sweep. So I'm going to put it 0 for my sweep length, and that makes them straight like that. And let's look at it from the base view, see where they are. See, now we need to rotate them to the side. So let's go to the radial position tab and rotate it 90 degrees, hit tab, and so now they're off to the side there like that. So that's exactly where I want them. And now let's attach these pod tubes to those. So let's click OK. Now, according to this drawing right here, it looks like they're capped off, so they're not hollow tubes. So we're not going to use a tube fin. We're just going to use a straight body tube, and we could put a bulkhead into it if we wanted to cap it off. Okay, so again, like we did before, we're going to add a pod to those fins. And what this warning is telling me is that I can only attach a pod to 1 fin at a time. So we're going to say, okay, we're going to split these into individual fins, and then we can put a pod on it. And that's what it did. So if I look here at my parts tree, well, I can't get down to it, but there's a fin set number 1 and then there's a fin set number 2 that are, so this one is number 1 and that one's number 2, or vice versa. I'm not exactly sure which, and it doesn't really matter. And again, we're going to say don't eject that, and we're going to call this the tube pod attachment point. Okay, let me see my drawing again. And it looks like it needs to be attached a little bit forward of the front of the tube, or the front of the fin. So if this is the front of my fin right there, this is the fin length right here. It looks like this tube extends a little bit forward of that. So I'm just going to slide it forward just a little bit right now so that I don't have to come back and do it later. And click OK. And so now we're going to attach a body tube to that. And I'm going to say that that's an 18 millimeter diameter. Or it could be a 24. Is that the same diameter as this one right here? Maybe it is. So let's call it a 24 millimeter. Click OK. And you can see it added that length, but it needs to be a lot shorter. So I'm going to shorten this up a little bit. It does hang past the bottom of our circular fin. So it's going to be like that. And let's call this the external pod body tube. And let's give it some color. Yeah, we'll leave it white, and we'll make it, I don't know, I'm trying to find a color I haven't used yet. Okay, you can barely see it right here. And click OK. So there's our one pod. And if I look at it in 3D, it's not looking too bad. If I want to cap it off right here with a bulkhead, I select the tube, and I want to come down to the part that says bulkhead, and I'm going to cancel out of the database. I'm just going to let it auto-calculate the thickness. I don't know, let's make it 0.125. So it's capping it off, and it's at the front of the owning part. So I can't really tell if that's the front of my owning part or not. So let me, yeah. I don't know if you can see it, but it's blue. Let me change the color to something that you might be able to see a little better. Let's make it orange. Okay, so there it is. It's capping it off just like we wanted it to. And the material, let's make it balsa wood. I don't know what it's made out of. Balsa wood. Okay. Okay, and I like that, so we'll leave that one there. Okay, so now we just need to duplicate it on the other side. And there's two ways I could duplicate it. One is I can duplicate the pod, or the other way is I could duplicate the whole fin, and it will duplicate the pod at the same time. So that's what I'm going to do. I'm going to take this other fin, which is this one right here, and I'm going to delete that. I got to find out what time it is here. Okay. So that fin right here, this fin, I'm going to delete and say yes. So it went away. And now I'm going to put it back, and I'm going to do that just by duplicating this one right here. So remember, we're going to copy and then paste it onto this rear body tube. Paste, and it did. It pasted exactly on top. And so now we're just going to rotate it. So we have two fin set number ones. So here's fin set number 2 dash 2, and I'm going to change the radial position. So if I look at it from the base, and if I changed it to a radial angle of -90 degrees, you can see it just swung it around. You see, if I would have done this, but it should have been -90. And remember, before I said if they're not coming off exactly sideways like this, like if it came off at an angle, you know, coming this way or coming that way, I would just change this radial angle right here. And then I would just do the same with the other one. And that's how easy it is to get it at the right angle. But I'm not exactly sure, so I'm just going to leave it at minus 90 degrees here. And click OK. So now I have fin set number 1 with a pod, and then fin set number 2 with a pod. And they're identical, they're just in a different position. So here's fin set number 1, here's fin set number 2. So here's number 1, and this one here is that's number 1, this one's number 2. All right, so basically we've just designed the Estes Boss, other than not having the correct dimensions, but changing the dimensions would be relatively trivial. You just go into each of the components and adjust it. So like if this body tube here at the front is not 9 inches long, then I would come over here to the body tube and say, it's not 9 inches, and then you can just adjust the length. So I'm not too worried right now that my dimensions are inaccurate, because once I got all the parts there, it's pretty simple. Okay, so let's launch this thing. Let's see, to launch it, let me save it first. So it's saved. Now to go to launch, come up here to this little button. This is our prepare for launch button. Click on that. And it says, in order to run the simulations, at least one body tube in each rocket stage needs to be designated as a motor mount. I did not do that, so it's telling me to select one of these tubes as the motor mount, and I know it's going to be this one right here, the one that says engine mount tube. And this is why I always change the names of my tubes so that I can tell them apart. So I just select it and hit OK, and now it knows that that tube right there in the middle is an engine mount tube, and it's 18 millimeter. It automatically calculated it, so choose engine, and we'll go C6-5, and we'll overhang 0.5 inches, so the rocket engine's going to hang out the back 0.5 inches, which you cannot see because it's kind of hidden right there. Flight events, deploy the parachute at maximum ejection delay, and our ejection delay was 5 seconds because we chose the C6-5. Simulation controls, I always leave that alone. Starting state, it's on a 36-inch launch rod. Oh, we didn't put the launch lug on there. So there's our launch lug. It doesn't. We'll say we're launching out of a tower. Launch conditions, 8-mile-an-hour wind. Hit the flight profile and let's see what this looks like. So here's the rocket sitting on the pad, and when we launch, the rocket takes off, goes up, and I'm going to speed it along, grab the slider, and so there it comes down, and it lands 721 feet downrange. And our apogee point, if I slide it back up towards the top, I can get an approximation. Right there, 755 feet. Okay, 756 is the exact number. So that's the Estes Boss. I'm going to hit save it again. So hopefully that answered the question on how do you make a round fin on your rocket. But what we also did was we did 2 transitions. We did 2 pods. If I wanted to add that launch lug, I can see there's one launch lug right here. I can't see, is there another one buried on this fin right there? But adding that launch lug, it's on a standoff. You can see that little standoff right there on that launch lug. Come back here to Rocket Design Components, and we're going to use a fin as the standoff. Again, it's going to be on that tube. So we have to select the tube, then we're going to add a fin, cancel out of the database, and this one, let's call it 1.5 inch long. 1.5 inches long is the root cord. The tip cord needs to be the same, 1.5 inches. I don't know if you can see, it's adding this gray fin right here as our fin. Sweep length is going to be 0, and then when I hit tab, this fin's going to jump. And I'm going to move the location. So now I'm going to move it to where it should be. And we only need one of them. So our fin count went from 3 to 1. And it looks to be almost, it can't be right in line with that fin. It's got to be off to the side a little bit. So let me go at this base view, and we'll kind of change things here. The height only needs to be a little bit bigger than the maximum diameter, which is that transition. So it puts the launch lug above that transition. So I'm going to change the semi-span right here, and I'm making it shorter. You can see I've made it a little bit shorter. Why did it make it 0? Let's go look at it from the side view. So it's right here, this red line. So let me change it to top view. So there it is. But there's got to be a semi-span there. It can't be 0. 0.2. Okay, so 0.2. I want this top edge to be just a little bit higher than that. 0.25. That's why I wanted to look at it from the base view. And it does look tall enough right there. But we need to move it off to the side. So again, radial position. We've been using the radial position a lot today. I can swing it right here, and then we'll put a launch lug on top of that. Okay, so there's the standoff. And again, I'm going to change the name. Let me go back here and I'll call this the launch lug standoff. And click OK. So when it's highlighted, but you can see I don't have either body tube or launch lug highlighted. So I need to add a pod. So we'll call this the launch lug pod. And it's not going to be ejected, so that's why I turn that off. And click OK. And now I can add, when I highlight launch lug pod, I want to add a launch lug, but it's not letting me. But I can simulate a launch lug as a body tube. So that's what I'm going to do. And then I just need the dimensions of the inside and the outside diameter. And this is where I go to the Apogee website, because the Apogee website is really good for this stuff. So let me open up. Here's the Apogee website, and I'm going to type in launch lug in the search bar. And there's a 1/4 inch. Let me go 1/8 inch. There we go, 1/8 inch launch lug. Okay, so the inside diameter is 0.142, the outside diameter is 0.162. So this is 0.162, and this one is 1.142. And then the length we said was 1.5 inches long. You can see that little green tube right there is our launch lug. Let's see it in 3D. Okay, so we've attached it right there. And if I look at it from a base view, you can see it's not in line with the fin. And if I look at it from a base view here, you can see a little bit better. So that's the, let's change the name to launch lug. And click OK. All right, so now I've really designed the Estes Boss. All right, that was a long, but we talked about a lot of different things there. Let's see, we've got any questions. Boy, people are talking about astronomy. Jeff asks, Tim, question, are all the fins taking part in the drag and stability calculations? And the answer to that is yes, all of them are, including, because we use the that launch lug standoff as a fin, we defined it as a fin. Fins do create drag and they do create lift. Everything is creating drag and lift except for these tubes. Because we attach them as a body tube and not a fin tube, or a tube fin right here. If it was a tube fin, it would. What makes this different than a body tube is this one will create lift and drag. A body tube does not. So that's just part of the calculations that go on behind the scenes. Johan says it's barely freezing at night where he is. Yeah, last night we got down to 6 degrees Fahrenheit here in Colorado Springs. Here at Apogee Components, our city is tearing up our street to replace the water line. And so our water is not coming up underneath the ground from the pipe. What they did was they laid a pipe along the surface of the street, and then they ran a garden hose from that pipe to our building. And that's how we've been getting water. And at night, it is freezing, and that garden hose, the first night that we had it, they told us to leave the water running so that it wouldn't freeze, but it still froze anyway. So that first night that they did that, and that was just a couple nights ago, we had no water the next day. So we couldn't flush our toilets or anything. So they thawed the line, and then they put in a bigger line. And now I notice that they've got a special heater unit on the hose. And so it's not a regular garden hose anymore. It's a special hose that runs hot water on the outside so that it won't freeze the water on the inside. But we still have to leave the water running at night. It's what's going on here at Apogee today. Okay, so let's see what time it is. Where's my clock? It says it's 2:56. I got 4 minutes. Any last minute questions? Did I miss any? I have to go back. There's a lot of chats going on today. There's a lot of people here. Carlos K says, gee, another catalog rocket with an invisible launch lugs. It says, Johan says, yep, Tim can also build a model in the simulator within an hour. Yep, I could have done it faster if I hadn't been talking, but I had to slow myself down. Johan says, Control Z to undo mistakes. Unfortunately, in RockSim, we do not have an undo command. So if you go here to edit, it says undo, but it actually doesn't do anything. Yeah, someday we'd like to add that feature. People are talking about the weather. Okay. I had another question from somebody, but we only got like a few minutes left. It was about how to correct engine files. So maybe I'll start talking about it now, and maybe we'll get to it next week. Okay, so he was saying this was a TARC team, and they were talking about the Aerotech E30. So the E30T motor right here, and it says that the total impulse is 33.6 Newton seconds. And he says that he is not sure if that is correct. So let me go here into RockSim and just double check that. So I'm going to load an engine here. And I'm going to choose an engine, but I want the E30, and the E30 is a 24 millimeter motor, not a 18. So to show a 24 millimeter, I have to say show all engines. And so now it's showing all the engines. And so now if I scroll down to the E30s, I went too far, went into the Fs. E30-T, it's showing the total impulse in RockSim at 39.512. So is RockSim correct? Is the website correct? What's the correct number? And if it's wrong, how do we fix it? Okay, so what we got to do is we got to go to the National Association of Rocketry website because they're the one that certified the motor. So it's nar.org. And maybe it's my internet's that slow. Okay, so here's the NAR website. We want to go down to Rocket Motors. Rocket motor information, certified motors. Let's try rocket motor information. And there's a picture of my daughter. Okay, this is not what I wanted. I want certified motors. Okay, so here's the certified motor list. Click on that. And what we're looking for is the Aerotech E30. So you got to scroll down, and I'm sure this is giving you vertigo because I'm going fast. So here's the E30-7, and it says this number here, 33.6, is the total impulse. Okay, so RockSim said 39, our website said 33. Well, let me just double check. 33.6. So our website is right. RockSim is wrong. So how do we fix RockSim? So I'm going to click on this because I want to see the thrust curve. And this will show me the thrust curve of this motor. And so this is what RockSim is not using. So RockSim comes, cancel out of here, cancel this. RockSim comes with a program called Engine Edit. So here's Engine Edit. So I just opened it up. And this is where we edit the engine files. So I'm going to go File, Open, and I'm going to look for the Aerotech motors. So here's Aerotech motors. Hit Open. And now it lists all the motors right here that Aerotech has that are in the current database. So I'm going to look for the E30. So here's the E30. So here's the thrust curve that it's using. And it's calculating the total impulse at 39.512. And the NAR website, this is what it looks like on the NAR website. And so we got to match this curve right here with this one right here. It looks pretty close. The burn time here is 1.02 seconds. In RockSim, I got 1.22, which I can see right here. So we got to shorten that burn time, and we've got to reduce the points. These points right here, we got to bring them down till it matches right here. So that's one way of doing it. Another way is if I open up a new browser, and if I go to thrustcurve.com, www.thrustcurve.com, and this is where we get our motor information from. It's still loading. I can't reach the page. Thrustcurve. Well, maybe it's thrustcurve.org. Yep, it was thrustcurve.org. Okay, so that's where we want to be. And then I'm going to type in E30 and hit search. And it found the Aerotech E30. And this one's correct. And it shows 33.6 Newton seconds. So I'm going to select it. And then, so here's a thrust curve, and then we need to download the file. So I'm going to come down here to RockSim files and hit download. and it downloaded it. And where did it put it? I think it put it in my downloads folder. This is the problem with using Windows, is I never know where it puts things. So I'm going to go back into RockSim, and I'm going to, it downloaded that motor file and it put it on my downloads folder. So now I'm going to add it to my database. I'm going to go File, Import Engine Files, and now I need to find that folder. I think it's in the downloads folder. There it is, Aerotech E30T-RSE. So I'm going to select it and say open. And what it did is it copied it to the data folder. Click OK. So here's the motor, and I'm going to say add. So it's going to add it to my database. Click OK. Okay, so now, oh, I'm in RockSim Pro, but same thing. I could have done it in RockSim. So now I need a motor, an engine kit with a 24 millimeter motor in it. So that's what I'm looking for. Not egg tosser, egg storminator, the vapor. Okay, so this rocket has a 24 millimeter motor mount in it. And now if I go to load engines, hit choose engine, and I say only show the engines that match the motor mount diameter. So it's just showing 24s. And if I scroll down till I get to the E30s, now there should be 2 E30s in there. And it does show 2 Aerotech E30s, but look at this. They're both showing 39.512. So what I downloaded here didn't match this total impulse here. So that tells me I've got to go back into Engine Edit and make the changes there. So let me go back to Engine Edit. I'm doing this really fast, and I'm probably confusing everybody. So I'm going to do File Open, and that was in my Downloads folder. Here's the Aerotech. Click Open. Now it's asking me, do I want to save these Aerotech ones? I'm going to say no. Okay, so here's the E30, and it's still showing 39.512, and that was downloading the file that I just downloaded from Thrust Curve. So this thrust curve file is wrong. So the only way to fix it is to take these points and slide them down until the total impulse equals 33.6. And there's a lot of points here. So I can just click and drag. See, every one that I drag down, watch that number right there. You can see it's coming down. And I'm gonna have to do it to all of them. I'm not even close yet. We're at 37, and I got to get down to 33. So I've got a long way to go. But this is the process. I got a message that popped up. That's not good. Let me see what that message said. Maybe my... I don't know what it said. I hope it's not my microphone. Jeff says, just try dragging those last 3 points to 1 second. I can drag them. Can't crisscross. I'm not sure if it's going to let me drag that the very last one. We're at 35.2. We're still not close. Oh, good. I was able to drag that one. But you can see I'm still too high, so I still need to move things down. Moving that one down is probably not. What it's doing is that number there, the total impulse, is the area underneath this curve. And so, and ideally what I want to do is to match the curve from this PDF right here. Get this exact to this 33.56 number. Thrust curve on his website, he used to have a program, create motor files. He's got a program called Thrust Curve Tracer that basically allows you to trace a motor file. Okay, so you can download it right here. Download the Windows version, there's a Mac version, there's a pure Java version. The Mac version, I think, requires the latest OS of Mac. The Windows, make sure you trust it before you open it. Okay. Let's say keep. Make sure you open it. Okay. Show more. Report this app as safe. I think this is a safe download. Enter the characters you see. I don't know what these characters are. 4GVDP. Thank you for submitting your feedback. But where's my where's my download? I hate Windows because I never know where things are. Downloads. Unconfirmed download. How do you want to open this file? I have no idea. I don't know. It's trying to open it in Acrobat. That's because it's like, because Windows, I'm afraid to hit this delete. See, then it deleted it, you stupid thing. Say, how do you copy download link? I don't know. I don't want to copy the download. I just want to open it. Keep anyway. Okay, now open file. This requires Java, which probably now I need to download Java. But if you can get this thrust curve tracer to work, I like this program for tracing them, because then when you trace it and then when you open it up in Engine Edit, this total impulse will match. Maybe by next week I can figure that out on this computer and we can try it. But I think we've gone way too long here. Yes, we went way over again. Jeff Gortowski says, can you round the nose cone? And the answer to Jeff is yes, you can round a nose cone really easy. Any nose cone, you just go open the nose cone. So you find the nose cone and you can, so here's the shape, and then you can just change it to like elliptical is rounded, and then you can change the length. Let me make this bigger so you can see it. Okay, so if I change the length of that nose cone, you can see that I can make it hemispherical if I want, you know, just by changing the diameter. So changing nose cone shapes is simple, super easy. Okay, I got screens everywhere that I don't know what's going on. So let's try this. Oh, there it is. There I am. All right, so we did a lot today again. We designed the Estes Boss. We added pods. We added circular fins on the Boss rocket. We added a standoff to a launch lug. And then we showed how to confirm that an engine file is correct. We don't make the engine files. We make the software. We don't make the engine files. So that's why some engine files can be incorrect. We don't have a lot of control over them, but we do allow you through Engine Edit to make those changes so that you can run good simulations. And we talked about, how to change a thrust curve using Engine Edit. And we also showed you how to import a motor into RockSim. Yeah, so we did a lot today. So we will be back next week. Next week will be the 17th, Friday the 17th, 2 p.m. Mountain Time, 4 p.m. on the East Coast, and it's kind of like 11 o'clock at night in the Netherlands where Johan is. So we'll be back next week. So I'm going to try how to end this broadcast using Windows. I've never done it before, so it may go on a little bit longer. So T-minus 5, 4, 3, 2, 1, go on.